Good morning, my dear students of first secondary. Today we are going to talk about a new lesson of trigonometry, and today's lesson is called Systems of Measuring Angles. Let's start. First Secondary Trigonometry, Unit 1, Lesson 1, Part 2, Systems for Measuring Angles, prepared by Mr. George Milad. Systems for Measuring Angles. First degree measure system. This measure depends on dividing the circle into 360 arcs of equal length. And we all know that 1 degree equals 60 minutes and 1 minute equals 60 seconds. Okay? For example, you can say measure of angle A equals 35 degree and 40 minutes and 36 seconds. Okay, you can say that measure of angle B equals 100 degree and 20 minutes and 45 seconds. This is what we called a degree measure system. It depends on dividing the circle into 360 arcs of equal length. Okay? Okay. Second, radian measure system. And in first secondary, we are going to study the radian measure system. So the first system is degree measure system, and today's lesson is talking about radian measure system. Okay, radian measure system. This measure depends on the following geometric reality. The radian measure of the central angle in a circle equal the length of the subtended arc over the radius length of this circle. So the radian measure of the central angle equal the length of the subtended arc by this central angle over the radius length of this circle. And we can draw a triangle for the law of theta radian, where theta radian will be equals to L over R. And if you will want to find the length of the arc, so the length of the arc equals R multiplied by theta radian. So theta radian equals L over R. L, the length of the arc, equals R multiplied theta radian. And the radius length of the circle equals the length of the arc divided by theta radian. Okay? As you can see, theta radian equals L over R, and R, the length of the radius of the circle, equals L divided theta radian, and the last one, the length of the arc equals theta radian times R. Definition. The radian angle is defined as the central angle whose arc length is equal to the length of the radius of the circle. So the radian angle is defined as the central angle whose arc length is equal to the length of the radius of the circle. That is to say that the length of the arc equal the radius of the circle. The relation between the degree measure and the radian measure. There is a relation between the degree measure and the radian measure is given by the rule theta degree over 180 equal theta radian over pi. Theta degree over 180 equal theta radian over pi. Here pi is 22 over 7 or pi equals 3.14. Okay? Very important remarks. If the radian measure of an angle is in terms of pi, then we can get its degree measure by substituting 180 degree for pi. I will give you some examples. Okay, let's take some examples. Here in this law, theta degree over 180 equals theta radian over pi. So if we want to find theta degree, you will write theta radian over pi. Theta degree will be equal to theta radian over pi multiplied by 180. Okay, and if we want to find theta radian, its law will be theta degree over 180 multiplied by pi. Okay, so these are the two rules. So if you have an angle of measure 30 degree and you want to convert it from degree measure to radian measure, you will use the rule theta radian will be equals to 30 over 180 multiplied by pi, and this equals to 30 over 180 by simplifying it will be 1 over 6 pi. Okay, and you can write it as pi over 6. Okay, if we have an angle of measure 90 degree, to convert it from degree measure to radian measure, we can find that theta radian will be equals to 90 over 180 multiplied by pi, and this will be equals to half pi, and you can write it as pi over 2. Okay, this is the way you change from theta degree to theta radian. Let's go to another slide. Remember, the sum of measures of the interior angle of triangle equals 180. We all know that the sum of measures of the interior angle of the triangle equals 180. Another remark, the sum of measure of the interior angles of a polygon of n sides equals n minus 2 times 180. For example, here, if we want to find the sum of measures of the interior angle of a quadrilateral, we all know that the quadrilateral formed from 4 sides. So, to find the sum of measure of each interior angles, so the sum equal n minus 2. Here we have quadrilateral 4 sides minus 2 times 180. So, the result will be 4 minus 2 is equals to 2 times 180 is equals to 360 degree. Okay, so the sum of measures of the interior angle of a polygon of n sides equals n minus 2 times 180. And you have to remember that the pentagon is 5 sides and hexagon is 6 sides and octagon is 8 sides. Okay, and the measure of each interior angle, of the regular polygon of n sides equals n minus 2 times 180 over n, where n is the number of sides. In the first one, we get the sum of measures of all the interior angles, but the measure of each interior angle, here we want to find the measure of each interior angle of a regular polygon. What is the regular polygon? The regular polygon is the polygon in which all the sides are equal in length and all the angles are equal in measure. All the sides are equal in length and all the angles are equal in measure. For example, 4 sides regular polygon is called square, 5 sides regular polygon is called regular pentagon, okay, and 6 side regular hexagon, the number of its side is 6 sides. Okay, let's go to some examples. Example number 1, find in terms of pi the radian measure of each of the following angles whose measure are as follows. Example 1, 120 degree. Here we want to find the radian measure of each of the following angles. 120 degree, 390 degree, and negative 315. Okay? Okay. To find the radian measure, here, solution, 120, you can write it as, we want to find theta radian. So theta radian equals 120 divided by 180 multiplied by pi. And here we want the answer in terms of pi. So we will write pi as it is. So we will simplify only 120 over 180. 0 cancel 0. Divided by 6, it will be equals 2. Divided by 6, it will be equals 3. So the result will be 2 over 3 pi. And we will write radian. So 120 degree is equivalent to 2 over 3 pi radian. Okay. 390. Here 390, first you can solve it by using two methods. The first one, theta radian will be equals to 390 over 180 multiplied times pi. Okay, put it on your calculator. 390 over 180, and this is equals to 13 over 6. You can write as 13 over 6 pi. Okay? Or the second method, you can simplify 390. You can say that 390 is an angle bigger than 360. So you can write 360 is equivalent to the angle equal 30 degree. So 390 degree is equivalent to an angle of measure 30, where its radian measure will be equals to pi over 6. Okay, you can convert 30 by the same way. It will be 30 over 180 multiplied by pi, which is equals to pi over 6. So you can write 390 is equivalent to 13 over 6 pi, or you can write it as pi is equivalent to angle of measure pi over 6. The last one, negative 315, theta radian will be equals, the last one, negative 315 over 180 multiplied by pi. Put it in your calculator. Negative 315 over 180, and this equals to negative 7 over 4 pi. Negative 7 over 4 pi. Okay, here is the solution for this example. 120, it will be equals to 120 over 180 multiplied by pi. This equals to over 3 pi. Or you can write it as 0.67. 390 degree minus 360. This is equivalent to an angle of measure 30, and 30 you can write it as 30 multiplied by pi over 180 is equals to 1 over 6 pi, or pi over 6, and this equals to, if you are trying to convert it into decimal form, 0.167 pi. Or you can write it, or you can solve it as 390 multiplied by pi over 180, and the result will be 13 over 6 pi. The last one, negative 315. This is another way to change this angle from negative measure to positive measure by adding 360, and the result will be 45. So the angle negative 315 is equivalent to an angle of measure 45, and 45 times pi over 100 is equals to 1 over 4 pi. Or you can solve it by negative 315 multiplied by pi over 180, and this equals to negative 7 over 6 pi as we solve it. Okay, let's check it again. Negative over 100, negative 315 over 180, and this equals to 7 over 4 pi. So this is will be 7/4 pi. Let's fix it together. This is 7/4 pi. Okay? Okay. Let's go to another idea. Find the degree measure. Find the degree measure in degree and minutes and second of each of the following angles whose radian measure is as follows. Here we have 2.43 radian, and we want to convert 2.43 radian, okay? We want to convert 2.43 radian to degree measure. So we will write 2.43 over pi multiplied by 180. Okay, this is the rule to convert from radian measure to degree measure. 2.43 over pi multiplied by 180. Okay, or we can write it as 2.43 times 180 over pi. The result will be 139.23, and you can write it in degree and minutes seconds. This is equals to 139 degree 13 minutes and 43 seconds by using this button on your calculator. Okay, ماشي. Negative 1.6 radian. Here we have a radian measure and we want to convert it into degree measure. So by using the same rule, negative 1.6 multiplied by 180 divided by pi, you will find that the measure of this angle will be 91 degree, 40 minutes and 24 seconds. You can write it as it is as a negative measure, or you can convert it into a positive measure. How can we convert from negative measure to positive measure? By adding 360. By adding 360. So the angle will be equals to 268 degree and 19 minutes and 36 seconds. The last one, 5/16 pi. We want to change it from degree measure, from radian measure to degree measure. So it will be 5/16 pi multiplied by 180 over pi, and by using your calculator it will be 56 degree and 15 minutes. Okay, let's go to another idea. Find the degree measure and the radian measure of the central angle that subtends an arc of length 28 centimeter in a circle of radius length 40. Okay, let's solve it first together. Solution. Here we want to find the degree measure and radian measure, theta degree and theta radian, of a central angle that subtends an arc of length 28. So the length of the arc equals 28, okay, and the radius length of the circle r equals 14. So the radius length equals 14. Okay, first we have to find theta radian, because we all know that by the rule theta radian equals L over r. So it will be 28 over 14. Simplify, divided 7, it will be equals to 4. Divided 14, it will be equals to 28 divided 14. This is equals to 2. Okay. So now theta radian equals to radian. All right, to radian. And we want to find theta degree by using the rule. Theta degree will be equals to theta radian over pi multiplied by 180. Okay, use your calculator. It will be 2 over pi multiplied by 180. The result will be equals to 114 degree, 35 minutes and 30 seconds. Okay, And this is the solution. You can see it here. Theta radian equals L over R, 28 over 14. This equals to 2 radian. We are going to convert from radian measure to degree measure. And the result will be 114 degree, 35 minutes and 30 seconds. Let's go to another example. Find the length of the arc in a circle with radius length r if it is opposite to a central angle with measure theta in each of the following. Okay, in the first case, here we have r equal 7.2 centimeter and theta equals 1.75 radian. R here equal 7.2 centimeter and theta equals 1.75 radian. How can we solve this problem? Here we want to find the length of the arc. What is the rule of the length of the arc? Let's draw the triangle here, L on the top, and we have R and theta radian. So to find the length of the arc, you multiplied R times theta radian. So the first example is very easy. You have R 7.2, theta radian equal 1.75 radian. To find the length of the arc, multiplied theta radian by R. So it will be 1.75 multiplied by 7.2. The answer will be 12.6 centimeters. So the length of the arc is 12.6 centimeters. The second one, R equals 15 centimeter and theta equals 104 degree, 58 minutes and 6 seconds. Here you can see that we can't find the length of the arc except by using the rule. The length of the arc equals R multiplied theta radian. Here we don't have theta radian, we have theta degree. So first we have to change theta degree. We have to convert from theta degree to theta radian by using the rule. Theta radian, okay, it will be equals to the angle 104 degree, 58 minutes, 6 seconds over 180 multiplied by okay. So the result will be equals, by using your calculator, the result will be 1.832 radian. Okay, as you can see here, theta radian equals 104 degree, 58 minutes and 6 seconds multiplied by over 180, and this equals to 1.832 radian. And to find here the length of the arc equals theta radian multiplied by R. We have theta radian 1.832 multiplied by the radius length, which is equals to 15, and the answer will be 27.48 centimeters. Okay, let's go to another example. Find the circumference of the circle. Find the circumference of the circle. Find the circumference of the circle. If there is an inscribed angle of measure 30 and subtends an arc with length 3 by centimeter. Okay, first you have to know that we are not dealing with the inscribed angle. Here we are dealing with the central angle, and we all know that the measure of the central angle is equals to twice the measure of the inscribed angle. So if we want to solve this example together, here he want to find the circumference of the circle. Okay, the circumference of the circle equals to multiplied by multiplied by R. So to find the circumference of the circle, we want to find the radius length of the circle. And all we know that the measure of the inscribed angle equals 30. So since the measure of the inscribed angle equals 30, therefore the measure of the central angle theta degree, it will be equals to multiplied by 30, and this equals to 60 degree. Okay, and to find R, we know that r, the length of the radius r equals L over theta radian. So we have to change theta degree from theta degree to theta radian. Okay? How can we change it? So theta radian will be equals to theta degree 60 over 180 multiplied by pi. So the result will be pi over 3. Okay? So theta radian will be equals pi over 3. Here to find r, which is the radius length of the circle, will be the length of the arc, and the length of the arc is given to me by 3 pi. So the length of the arc 3 pi divided by pi over 3. Okay? Here pi will cancel pi, and the result will be 3 divided 1 over 3, which is equals to 9 centimeter. So now the radius length of the circle is 9 centimeter. So the circumference of the circle will be 2 multiplied by pi multiplied by the radius length, which is equals to 9 centimeter, and the result will be equals 18 pi centimeter, or approximately equals 56.55 centimeter. Okay, let's go to another example. This example is one of the important example in this class or in this session. ABC is a triangle in which measure of angle equal 50 degree and the measure of angle B equals 1 over 3 pi. Find the measure of the third angle in degree and radian measure. In degree and radian measure. Okay, let's draw the triangle ABC. Here we have the triangle ABC. The measure of angle A is 50 degree and the measure of angle B equals 1 over 3 pi. Very important remark to you. If we want to change, here we have measure of angle B equals 1 over 3 pi. Okay? In the very important remark, we know that pi in the radian measure is equivalent to 180 degree in the degree measure. So to find the measure of angle B, which is given to you by radian measure, so measure of angle B equal 1 over 3 pi, this is a radian measure. If you want to change it directly into degree measure, you replace pi by 180. So it will be 1 over 3 multiplied by 180, and this is equals to 60 degree. So now we have measure of angle B, it's equals to 60 degree. We all know that the sum of measures of the interior angle of the triangle is equals 180. So measure of angle C, it will be equals to 70 degree. Okay, so the measure of angle C, here he wants to find the measure of the third angle C, so C equals 70 degree. But we want this measure in degree measure and in radian measure. The degree measure is 70 degree. If we want to convert it into radian measure, so theta radian will be equals to 70 over 180 multiplied by pi. So it will be equals to 1.222 radian, and this is the answer of this question. Okay, again measure of angle B, measure of angle B here equals 1 over 3 pi. So we can replace pi, this is the idea of this problem, we are going to replace pi by 180. 1 over 3 multiplied 180, so measure of angle B equals 60 degree. Measure of angle C equals 180 minus 50 degree plus 60 degree, the result will be 70 degree. We want to convert the 70 from degree measure to radian measure by using the rule. Theta degree will be equals to 70 over 180 multiplied by pi, and this is equals to 1.222 by radian. Okay, thank you so much. Until we meet again next time, goodbye and good luck.